Section 14.1, Roots and Radicals. In this video, we're going to be discussing how to evaluate square roots and how to evaluate cube roots. So we'll begin by looking at some terminology. We need to understand that when we see the symbol, that is called a radical sign. The number that we put under the radical sign is called the radicand. So if we have an expression like the square root of 64, the 64 is the radicand. Then we have this is our square root or our radical sign, and the entire thing is called a radical or a radical expression. Now, if we let a be a non-negative real number, then the square root of a is called the principal square root, and it's understood that that's a positive value. If you have a negative square root of a, that's called the negative square root of a, and that would be a negative value. If we take the square root of a negative number, those are non-real numbers. So think about square roots to begin with. If I ask what's the square root of 4, what I want to know is what number times itself would give you 4. Well, we know that that's 2. So the square root of 4 would be 2. The negative square root of 4 would be negative 2. So that's what we were talking about in our previous discussion. But now what about the square root of negative 4? Why is that not real? So if I look at the square root of negative 4, I want to know what number times itself would give me negative 4. Well, we know it can't be 2 times 2 because a positive times a positive is a positive. So what about negative 2 times negative 2? Well, if I multiply negative 2 times negative 2, that's also positive 4. So that's not equal to negative 4. So there is no number times itself that would give me negative 4. So the square root of negative 4 is non-real. Now, in the next example, we're going to actually spend some time evaluating some square roots. So we talked about the square root of 64 earlier. 64 has 2 square roots, a positive and a negative. If we have just the square root sign, the radical sign, it's understood that we want the positive root. So when I ask for the square root of 64, I want to know what number times itself would give me 64. Well, we know that that would be 8. But if I have the negative square root of 64, what I'm going to do is I'm going to take that same answer and I'm going to make it negative, because the negative in the front means find the square root of 64 and use the negative of that answer. Now, knowing that 11 squared is 121, then we can say that the square root of 21 would have to be 11, because 11 times 11 is 121. And negative square root of 121 would be negative 11. Since 0 squared is 0, the square root of 0 would have to be 0, because 0 times 0 is 0. The square root of negative 25, again, thinking about what number times itself would give me negative 25, well, there is no number that does that, so we call that a non-real solution. What about the square root of 16 over 25? Well, we know that 4 over 5 times 4 over 5, or 4/5 squared, is 16 25ths. So the square root of 16 25ths would be 4/5. And notice, really, all we did was take the square root of 16 was 4, and the square root of 25 was 5. The negative square root of 0.009, then I would have to have negative 0.03 times itself to give me 0.0009. The next thing we want to discuss is cube roots. If a is a real number, then we write the cube root of a as the radical with a 3 right here above your radical sign. Now, looking at our cube root sign, if we have the cube root of a, the number 3 is called the index. In a square root, like we've talked about before, it's understood that your index is 2. So it's not normally written, just like when we write x, we understand that that means x to the 1, or x could also mean 1x. In radicals, our index is understood to be 2. Now let's look at evaluating some cube roots. So if I ask for what's the cube root of 8, I want a number times itself 3 times that would give me 8. Well, I know that 2 times 2 is 4, times 2 more is 8. So the cube root of 8 would be 2. If I do the cube root of negative 216, now previously we said when we take the square root of a negative number, that's not real because I can't find a number times itself that would make me have a negative answer. But I can do the cube root of a negative number. So I want a number times itself 3 times that would give me negative 216. Well, that actually turns out to be negative 6. Because negative 6 times negative 6 is positive 36. And positive 36 times negative 6 is negative 216. So the cube root of negative 216 would be negative 6. And then if I'm doing the cube root of 1/27, just like before when I did the fraction and a square root, we can really just do what's the cube root of 1? So what number times itself 3 times would give me 1, and that's 1. And the cube root of 27 would be 3, because 3 times 3 times 3 is 27. So the cube root of 1/27 would be a third. Now we're going to talk about some terms describing the types of answers that we get when we work with radicals. We can discuss having what we call a rational number for a solution. A rational number is a number that can be written in the form of P over Q, where P and Q are integers. So if I can write my number as a fraction, then it is a rational number. Another way you can think of rational numbers is they either terminate or repeat. So 3 would be a rational number because it terminates. It's just 3. Or I could have 3.4242 and so on would also be a rational number because it repeats. Irrational numbers are numbers that are not rational. There's some irrational numbers that are pretty common that you talk about. One of those that we've already discussed is pi. And remember, we talked about that we were going to let pi be 3.14, but it does go on forever and it doesn't repeat. So that would be an example of an irrational number. Common irrational numbers are square roots that are not perfect squares. So if I had like the square root of 20, there is not a nice number that times itself would give you 20. If you work out the square root of 20, that's an irrational number. But the square root of 25 is rational because the answer would be 5. So if you're doing the square root of something that's not a perfect square, it's irrational. And if it's the square root of something that is a perfect square, it's rational. And then the last thing that we want to talk about is non-real numbers, and we've already discussed those, and those are always formed by the square root of a negative number. So without actually calculating these, let's determine whether they are rational, irrational, or non-real. So the square root of 34, I want to ask myself, do I know a number times itself that would give me 34? And there is one, but it's a decimal, so that would be irrational. 34 is not a perfect square. How about the square root of negative 25? Well, we know that the square root of a negative number is non-real. The square root of 121? Well, if we remember, 121 is 11 times 11, so the square root of 121 would be 11. And the cube root of negative 27? There is a number times itself 3 times that would give me negative 27, and that would be negative 3. So this would be rational. And our answer for the square root of 121 was also rational because the answer was 11.